Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. Topic that we are going to discuss in our today's video is arithmetic sequence. Arithmetic sequence is a sequence in which the difference between consecutive terms is constant. Here we are going to see about the common difference, general term. Also let us discuss about the partial sum of an arithmetic sequence. Now we are going to discuss about this D. This D is called common difference. Since this difference is common to all the consecutive pairs of terms, it is called the common difference. It is generally denoted by D. If the difference in consecutive terms is not constant, then the sequence is not arithmetic. The common difference can be found by subtracting two consecutive terms in the sequence. Okay. Formula for the common difference of an arithmetic sequence is: you can take any two consecutive terms from the sequence and then just find the subtraction. You can find the difference between that. That would be the formula for common difference. Hope you got an idea on this D. Okay. Now let us see what is meant by general term. Arithmetic sequence is a linear function. We generally use this formula, right? Y is equal to mx plus b, where m is the slope and b is the intercept. So we write an is equal to a1 plus n minus 1 d, where d is the common difference. General term can also be written in this way: common difference and the constant, d times n plus c. Okay. A recursive definition: since each term is found by adding the common difference to the previous term, you can write, here is the recursive definition. For any term in the sequence, we have added the difference one time less than the number of the term. For example, for the first term, we haven't added the difference at all because 0 times. For the second term, we have added the difference once. For the third term, we have added the difference 2 times. So, the formula for general term of the arithmetic sequence is an is equal to a1 plus n minus 1 d, where d is the common difference, as we all know, and a1 is the first term in the sequence and an is the nth term. Okay. In arithmetic sequence, once you are familiar with this formula, you should also know about the partial sum of an arithmetic sequence. So let's discuss about that. A series is nothing but the sum of a sequence. We want to find the nth partial sum, or the sum of the first n terms of the sequence. We will denote the nth partial sum as s with suffix n. Okay, I'll give you one example. Consider this arithmetic sequence series. S5 is equal to 2 plus 5 plus 8 plus 11 plus 14. There is an easy way to calculate the sum of an arithmetic series for this one. The key is to switch the order of the terms. We all know that addition is commutative. So, changing the order does not change the sum. So now we are going to add those two equations together. I have just rearranged the order. Just change the order. But the sum is same. Okay. Now let's add these two equations together. S5 plus S5 would be 2S5. And on the right side, I'm just going to add these numbers. Please notice that each of those sums on the right hand side is 16. Instead of writing 16, the sum of the first and last terms 5 times, we can just write it as 5 times 16 or 5 times 2 plus 14. So 2s5 will be equal to, hope you're clear with this point. Finally, divide the whole thing by 2 so that you'll get the sum and not the twice the sum. So dividing the entire equation throughout by 2, we will get. Hope you're clear with this example. I have purposely not simplified the 2 plus 14 so that you can see where the numbers come from. This sum would be 5 over 2 times 16 or 5 times 8, which is equal to 40. Now, if we try to figure out where the different parts of that formula come from, we can conjecture about the formula for the nth partial sum. The 5 is because there were 5 terms, n value. So the 16 is the sum of the first and last terms. Am I right? A1 plus an. And the 2 is because we added the sum twice and it will remain a 2. Therefore, the sum of the first n terms of an arithmetic sequence is going to be. So this is how we have derived the formula for the partial sum. Hope you're clear with this formula. Okay. There is another formula that is sometimes used for nth partial sum of an arithmetic sequence. It is obtained by substituting the formula for the general term in this formula and simplifying. So the preferred method is to go ahead and find the nth term and then just plug that number into the formula. So we will get. Hope you're clear with these two formulas. You can use either of the formula. Most probably you will be using this formula. If necessary, you can also use this formula in problem solving. Okay. Hope you got an idea about the partial sum. Let me take one example. Please consider this example. Find the sum from k equal to 3 to 17 of 3k minus 2. Okay. First, let me write this in summation format. We are supposed to find the sum. Okay. Let's find the first term. The first term is found by substituting k equal to 3 in 3k minus 2. So that we will get, replace k by 3 in this expression 3k minus 2 and then simplify. It would be 9 minus 2, which is nothing but 7. Then let's find the last term. Last term is found by plugging in this number, the highest one, 17 in this expression. So we will get, replacing k by 17, we will get, multiply 17 by 3, subtract 2. That would be 49, right? Now let's find n. n is nothing but 17 minus 3 plus 1. That would be 15 terms. So the sum would be, just plug in a1, an, n in the formula. Replace a1 by 7, an by 49 and n by 15. Okay. By simplification, we will get 15 over 2 times 56. That is going to be 420. Am I right? Please note that there are 15 terms there. When the lower limit of the summation is 1, there is a little problem figuring out what the number of term is. However, when the lower term is any other number, it seems to give people difficulty. So no one would argue that if they went from 1 to 10, there are 10 numbers. However, the difference between 10 and 1 is just 9. Am I right? It will be a little different, very small number. So when you're finding the number of terms, it is the upper limit minus the lower limit plus 1. You can also note this point. Hope you're clear with this example. Okay, let me take one example and explain you how to check whether the sequence is arithmetic or not. I have posted two sequences, sequence A, sequence B. In sequence A, we have -1, -3, -5, negative sign. It keeps going on. And in sequence B, we have -3, 0, 4, 7. Sequence A is an arithmetic sequence because every pair of consecutive terms has a common difference of -2. You can also check. So what is the difference between these two? You can also, if the numbers are very small, you can imagine a number line and plot those points to find the difference. That would be one of the easiest way to find the difference. Just subtract the numbers and check. -3 minus 1 would be -2. If you subtract these two numbers, you will get -2. If you subtract these two numbers, you will get -2. So the common difference is -2 for every pair of consecutive terms. On the other hand, if you check the sequence of B, you can say that this is not an arithmetic sequence. You can check by finding the difference. 0 minus 3 would be 3. 4 minus 0 is 4. 7 minus 4 is 3. The difference is changing. They are not the same. That is not constant. So there is no common difference among the pairs of consecutive terms in sequence B. So this will not be considered as an arithmetic sequence. Are you getting this point? Let me post one example how to find the next term in the sequence when few of the numbers are given. Here is the next example. We have -6, -1, -4. Let's find the common difference. If you subtract these two, it would be 5. If you subtract these two, it would be -4, negative of, third term is a positive 4. So the common difference for these terms would be 5. To get the next term, add the previous term by 5. For example, from 4 to 9, you add 5 to 4 to get to 9. Am I right? So it would be 9. Hope you're clear with the basics of arithmetic sequence. In case if you have any query regarding this topic or any topic that is related to arithmetic sequence, kindly let me know. If you need, I can prepare a video for that topic too. See you in the next video.